Now that we have studied uninformed search, let's turn to informed search strategies. Unlike uninformed methods, informed search uses extra knowledge about the problem beyond just the initial state actions and the goal state or the goal test. This extra knowledge usually comes in the form of a heuristic function written as h of n. H of n estimates the cost of the cheapest path from node n to the goal. Importantly, for a goal node, we always require that h of goal equal to 0. The general framework we'll use is called the best first search. But before that, we talk little more about the heuristic. Heuristic is called a rule of thumb, simplification, or educated guess that reduces or limits the search or solutions in domains that are difficult and poorly understood. The knowledge is useful, but not necessarily correct. And that is a heuristic. Heuristic algorithms use heuristic knowledge to solve a problem. A heuristic function h of n takes a state n and returns an estimate of the distance from n to the goal. That's the job of a heuristic. So this entire concept of informed or heuristic based search strategies kind of starts from the best first search or the greedy best first search. It works just like uniform cost search, but instead of choosing the lowest g of n, which was path cost so far, that means the cost from Arad to Zerin, the 75, that was g of n, we choose the lowest f of n, where f is some evaluation function. The choice of f of n defines which strategy we are running. So about the greedy best first search, which is the first strategy, the evaluation function is simply f of n equal to h of n. This means the algorithm always expands the node that appears closest to the goal according to the heuristic. For the Romania map problem, we use the straight line distance heuristic, or h of SLD, the straight line distance from any city to Bucharest. See here in this table, Bucharest to Bucharest distance is 0, and the other distances corresponding to other cities are straight line distances, or as the crow flies distances from individual cities to Bucharest, like Arad to Bucharest 366 miles, Craiova to Bucharest 160 miles, and something like that. Please understand, straight line distances are the shortest path distances between a pair of points. But in a real road network, straight line distances practically doesn't matter, because the road network distances are often larger than the straight line distances. However, that gives us a very good estimate of the bound. This is the Romania map problem. We have already said the straight line distance from any city to Bucharest, we are considering a straight line SLD, HSLD. For example, HSLD of Arad is 366. Let's see how it works from Arad to Bucharest. Okay? So, how it works. So, greedy best first search example. Now from Arad, the closest looking city is Sibiu. So, when I expand Arad, I will get Sibiu, Timisoara, and Zerind. And now from this table, I have the idea of straight line distance from Sibiu to Bucharest, which is 253, Timisoara to Bucharest, which is 329, and from Zerind to Bucharest, which is 374. So among them, CBU is the closest among those first level of children. Okay, so now from CBU, the closest is Fagaras. So from CBU, we expand CBU and we get again Arad, Fagaras, Oradia, and Riminsiu-Vilsia. So you have to understand we have again expanded Arad because it's a tree search algorithm and we need to lay out all the possible nodes. So CBU Arad is one possible way. We can ignore it completely. If we consider graph search and we say, oh, these are the visited node, already visited, and we can ignore it. But otherwise in the tree search we need to consider it, but the distance is 366, whereas from Fagaras to Bucharest is 176, which is definitely cheaper than any other distance. So you have to consider Arad, Fagaras, Oradia, Riminsiu, Vilsia, Timisoara, and Zerin. And among these 6, the cheapest is Fagaras. So now from Fagaras, if we extend it one more time, of course you see we get CBU, but Bucharest too. And Bucharest is our goal node, so our search stops here. So it's done very fast, very few expansions. But greedy best first is not guaranteed to be optimal. You have to understand that. Greedy best first is not guaranteed to be optimal because the route found is Arad, Sibiu, Fagaras, and Bucharest, which is 450 kilometer or mile, whatever unit you use. But there is a shorter route from Arad, Sibiu, Riminsiu, Vilsia, Pitesti, and Bucharest, which is 418 kilometer. And it's shorter. So that's the optimal route. So that's 32 kilometer shorter than the other route our system, our greedy best first search algorithm has found. That's why it's called greedy. At every step, it just jumps towards the goal without considering the longer term cost. So finally, note that the tree search version is incomplete, okay? Because in tree search, it can expand, you can have infinite loop, Arad, CBU, Arad, CBU, Arad, CBU in that way. So, even if it's finite space, still it can get stuck in loops. The graph search version is complete for finite spaces, but still not optimal. Graph search means the one which considers visited nodes. It's complete. That means it can find the solution like we did, but it's still not optimal because it may not find the best route. It just greedily finds the first route, basically. Time and space complexities can be as bad as order of b to the power m, but in practice, if you choose a good heuristic, it makes it much more efficient. Here I want to show you where it can be stuck. So here, if you see from Bucharest, there is a path to Nimt, which goes to Yasi. But if we are considering the path from Nimt to Fagaras, and if we had the straight line distance, you will see the straight line distance from Yasi to Nimt should be this way, Nimt and Fagaras, although there is no real path. So there might be considerations, there may be possibilities where the solution will not be able to complete even if it's a finite graph.